permutations and combinations. Whoop! Now we're going to look at permutations versus combinations. All right, both of these are a way of choosing a smaller group from a larger group. All right, there's one specific difference. A permutation, the order matters. And for combination, the order doesn't matter. Another way to think about that is that for combination, we're just making a group. And for permutations, we might have positions like first, second, third, or fourth, or president, vice president, secretary. Looking at my first example, it says, how many ways can I make a group of 3 from 10 possible choices? Notice it just says a group. There's nothing to specify that the order of the group matters. So we're going to use a combination. The way I'm going to set it up is that my larger number is always written first. We're going to use calculators or Desmos to solve. This is what it would look like if I was typing in my calculator, but I'm going to add in a video of what it looks like to type it into Desmos. But when I do 10 NCR3, I'm making a smaller group of 3 out of a larger group of 10 when the order doesn't matter, and this ends up being 120 possible outcomes.
First example, I need to put in 10 NCR3. If I scroll down here to the little keyboard looking thing, over here in functions, in stats, there is my NCR NPR. So I just click on NCR. Remember, big number goes first, so it's 10, comma, 3, close parentheses. My answer is 120.
So just make sure that if you know that the order doesn't matter, we're going to use NCR. And that's the way it looks on both the calculator and Desmos. NCR. Looking at this problem, it seems kind of similar to the problem before. How many ways can first, second, and third finishes happen if there are 10 people in the race? Notice we're still making a group of 3, but this time we have the designation of first, second, and third. It matters who comes in first. It matters who comes in second. It matters who comes in third. So the order of the finishes affects the group we're looking for. So this would be a permutation. So once again, we're using 10 and 3, but this time we're using 10 NPR3. This is how it would look if I were to put it in my calculator. I'm going to show you how it would look when I put it into Desmos.
Example number 2, I need to do 10 NPR3. I go down here to function, stat, NPR. Larger number goes first, small number goes second. My answer is 720.
But 10 NPR3 equals 720. All right, so notice there is a designation of something that tells me order matters. All right. Also, if you go back and look at example 1, you'll notice that they were both groups of 3 from a large group of 10, but a permutation when order matters is significantly more possible outcomes than when order doesn't matter. What if we're the aliens and we sent a meteor here to get rid of the hostile inhabitants and it took 65 million years to terraform the Earth? Next one, I got 15 pies. How many ways can I make a group of 9 pies? Once again, just making a group. There's no way to designate that order matters, so I'm using NCR. It is a combination. Big number gets listed first, NCR 9. Once again, I'm going to show you how it looks in Desmos.
Example number 3, we need to do 15 NCR 9. Click on functions, NCR. Large number first, comma, second number 9, 5,005.
But this equals 5,005. Order doesn't matter. There's nothing to designate that order matters. For this last problem we're going to look at, the question says, how many ways can I make a group of 2 out of 5 choices if order matters? We're not given titles for my choices, but we are told in words that order matters, so I automatically know I'm doing a permutation. So, big number goes first, small group goes second. This is how it looks when I put it in the calculator. I'm going to show you how to put it into Desmos.
You need to type in 5 NPR2. function NPR 5 comma 2, and we find out that it is 20.
And this would equal 20. Permutations and combinations. Now go do your work, and then have some fun.